Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about database buffer cache. So this is the Oracle abstract picture of Oracle server, and then which is consist of a instance and database files, and then instance consist of memory structure and database processes. And we have already explained you about the files, and then in this set of videos we are discussing about the memory structure, and in this particular video we are going to discuss about database buffer cache. So what is database buffer cache and why we need buffer cache, and then what are the algorithms that is there to manage the database buffer cache. That's what we are going to learn in this set of videos. Okay, so let's try to visualize something. We have a database which is like consist of different DBA files and all, and as you learn that the data is stored inside a database block which is called DB block, and there are multiple DB blocks, and then this DB block is the size of the DB block is given in the init.ora parameter by DB underscore block size. So let's say I created my database with database block size with 8 kilobyte. That means all this block inside here is 8 kilobyte, and then I have data inside those blocks. Like whenever we are doing an insert into employee, the exact data, those things is going to store here in this database block. Alright, so there's plenty of those database blocks, and then we discuss about extent, segments, and table space, and so on. Alright, so whenever we are going to do a select star from EMP, the employees data is going to be what are stored in the database block in the file. Those things are going to come to the random access memory and then store here. Okay, so let's say this is an so this is your disk, and this is your random access memory, and then inside random access memory there is a area called SGA, and inside that SGA there is an area called DB buffer cache. So what is going to happen, this block is going to come and then store in this area called DB buffer cache. So essentially DB buffer cache is a memory structure inside the system global area which stores the database block from the database. So when you do the select star from EMP, assuming that EMP has 14 to 15 rows and the actual data size is less than 8 kilobyte. So in that case, if all the employees data is stored in one block. So when I do select star from EMP, Oracle's dedicated server process is going to copy this thing to the memory. Okay, and then this is in the memory right now. So let's say after some time, what I'm going to give select star from department. Similarly, what is going to happen, it will going to check if department's information is there already in the buffer cache or not. If it's not there, then it's going to go and then going to read from the department block. So which is for example, let's say this is department block, and then it's going to put this department block in the DB buffer cache, and it will continue. Let's say after some time I'm going to give select star from EMP. So whenever I'm going to give select star from EMP, in that case the dedicated server is going to look at the DB buffer cache, and it indeed finds out that there is the employee data is already available in buffer cache. So in that case it is going to give you the answer right away by reading the buffer cache area. Okay, so this is called a cache hit. That means we are getting the data from the buffer cache. We do not have to go in the third scenario. We do not have to go to the file system to get the data. So it is always in since cache hit is getting from the random access memory. Therefore, everything which has a cache hit is going to be faster. Right? So if it's going to faster, then is not it a good idea that anytime then after that, let's say somebody is going to give select star from T. Select star from T, maybe it is not there, but it will for the first time we can read from the file and then have T here, right? table T's data block, and then and so on and all this thing, right? For the consequent, let's say like in the step 7 I'm going to do select star from T. In that case I'm going to get that data from the buffer cache, so therefore a cache hit. So that means after a warm up time we are probably going to get everything from the buffer cache, provided the size of the buffer cache is same as size of the database. Okay, so that means we can, so cache hit is always good. And then to get a cache hit, to ensure that we are going to get a cache hit, we need to make sure that the buffer cache, size of the buffer cache should be equal to size of the database. So let's take a look. In case of the size of the database, like a very ordinary database might have gone to 100 GB. Okay, the size of 100 GB. That means I need, in my random access memory or my RAM, I need to have a space for 100 GB. And as you know, this may not be possible. So that means the, because this is very expensive memory, the random access memory is more expensive than the disk. So here's a ballpark figure. For example, a 1 GB RAM may cost you around 30 US dollar, whereas a 1 terabyte hard drive might cost you about $100. Okay, so therefore you can see the difference, so therefore it is not possible to have a size of your buffer cache which to be equal to the size of the database. If that is the case, then what is going to happen, like if I'm going to do select star from T, then select star from T1, then so block buffer, so eventually, like after doing couple of queries, it might possible that I'm going to fill this database buffer cache completely. So if I'm going to fill this database cache completely, let's say at the step 8, after I do some more queries, I'm going to fill this buffer cache. So in step 9 I'm going to do say select star from P, and assume that this table has never been accessed before. So that means you will not get the data for P in the buffer cache. That means you have to go to the disk and read it to the buffer cache. But if you look, like we do not have any more space. So that means some of these blocks is going to be rewritten, right? That means I'm going to remove whatever I have, probably whatever I'm done in the first, I would have rewrite with the data block from select star from TP. So if that is the case, then Oracle needs to intelligently see which ones to be removed from the buffer cache, and which one should be kept, right? So that means there should be a way to keep blocks in buffer cache and release from buffer cache. So that is how it comes to the management of buffer cache. So the management buffer cache happens like this. Say for example, this is our DB block buffer, and then for simplicity I'm going to make sure that I'm going to divide this, this cache. So this is our DB buffer cache, and I'm going to divide this DB buffer cache into say multiple blocks, right? Let's say for simplicity I have 16 blocks. Okay, so 16 blocks is there, right? And let's say name it. So this is 1 2 3 4, then 5 6 7 8 9 10 11 12 14 15 and 16. Okay, so this is what so the database is just started and I do not do anything, so therefore this block buffer, buffer cache, nothing is there. Then let's say I do select star from EMP. So select star from EMP brings a block and then keeps it in this one. Okay, so what I'm going to do, I'm going to maintain a list. Let's say this is a list, and the list there are two ends. This is a top and this is bottom. So what I'm going to maintain in this list, the address of this area. Okay, so since I have occupied one, so therefore I'll say that okay, so one is in the topmost. Then let's say I do select star from department. Select star from department. So in that case I'm going to basically read from the database file and get the department block and put it to this place, right? So since this is happened after 1, so therefore what's going to happen, 2 is going to come here and 1 is going to go down. Okay, so 2 is in the top, 1 is, so whatever the last time I'm accessing, those things will go up, right? So let's say what I'm going to do, I'm going to do in step 3, I'm going to select star from T, another table. So in that case I'm going to use 3 now. So if I'm going to use 3, then this list is going to become like this. So this list is going to become first 3, then 2, and then 1 is go down. Let's say after after step 4, I'm going to use select star from EMP. That means the first thing. If I do select star from EMP, that means it is going to read from this block, right? So that means 1 is again reused or retouched. So therefore 1 is going to come to top. So in that case my list is going to look like 1 here, then 3, then 2. Okay, so this is my new list, 1, 3 and 2. So on, and then finally, like whenever I'm going to read to all these 15 16 blocks, so then all the list is going to have 16 entry. So the 16 entry, the top entries are going to show me what is the last used. Okay, whereas the bottom is going to what are the least used. Okay, so this is otherwise top end, or it's called MRU, that is most recently used, and this end is called LRU, or least recently used, and this list is called popularly as LRU list, and this algorithm is called LRU algorithm. So this is how database buffer was managed before Oracle 8i. Okay, so before Oracle 8i, what is going to happen is that we are going to put this thing, and let's say after we complete, after we fill all 16, and then say after that we're giving another query, and that query requires some blocks, but looks like all blocks are being occupied. Let's say during that time, whenever this thing happened, let's say database block number 5 is in the bottom and I need one block. So in that case what I'm going to do, I'm going to rewrite 5. Okay, so 5 was written something back, and then I'm going to rewrite on 5, and then I'm going to rewrite whatever I'm going to get from this query select star from P. So P's data is going to be rewritten on top of whatever was existing before. So this is how, with a small amount of buffer cache, I can manage who are my popular data blocks, and I can always, by using this kind of algorithm, I can keep those popular um, data blocks. So the goal here is to keep what are the popular blocks and then release what are not popular blocks. Let's say if the select star from EMP is always being queried by multiple users, that means select star from EMP, if we keep the data blocks of EMP in the buffer cache, then our query is going to faster because it can read directly from the database buffer cache. So that is the idea behind the LRU list. But here is a big problem. The problem is that, say for example, so I have all this thing happening, I'm getting from employee, from department, from T, from P. Assume that I have a table called A. That table is itself, say, a huge table of 1 gigabyte. That means the total number of data blocks, let's say that is 50. So if the total number of database blocks are 50, if I do query select star from A, that means I need 50 blocks in the buffer cache. How many blocks I have? I have 16 blocks. So therefore what is going to happen, that I am going to write all these 16 blocks with the data from the table A, and then the remaining 34 it can stay in the database. So that means I can partially fill the buffer cache. So if that is the case, that means let's say all these queries or whatever was there, those data is all gone. What you are seeing right now in the buffer cache, the data of table A. Let's say to make this case more bad, that this is just one time, after this nobody really call anything select star from A. So that means what I am seeing right now, I am seeing that unnecessarily my buffer cache is flooded with the data from table A, whereas other data blocks are suffering. And let's say after this somebody is going to do select star from EMP. So in that case, because since my database block buffer is flooded with A, I have to again go to the DB and then get the employee information and then going to store somewhere. Okay, so rewrite, basically rewrite somewhere. So let's say I'm going to rewrite here. So the problem is that, like, because of a one full table scan, which is a one full table scan of a big table, it may happen that my LRU algorithm is going to fail. So in that case, what they come up with, a algorithm called modified LRU algorithm. In the modified LRU algorithm, if you do a full table scan of a big table, then instead of flooding this thing, they want to, Oracle will take limited amount of data from the database and keep those things in the LRU end, not in the MRU end, in the LRU end of the list. Okay, so that means I do still have all this other database block, whatever I'm doing from employee, from department, will be present. So that is called modified LRU list. But modified LRU algorithm is not also going to work when we do a index scan range. In case of index scan range, if your leaf nodes are going to have multiple blocks, then it may happen that it will flood the buffer cache again. So don't worry if you do not understand about index scan. So but what I'm saying is that modified LRU is going to fail in certain cases, and still that flooding of buffer cache can happen. If flooding of buffer cache happen, then again a lot of other data will not be available. That means a lot of other users are going to have a bad response time, or they will suffer. So after that, what Oracle comes up, they comes up with a new algorithm called touch count. So what they did, that in the LRU list, whatever we had before, they divide this LRU list into two parts. The top part is called hot list and the bottom part is called cold list. So the top part is called hot list and bottom part is cold list. And now let's say assume that we have a this is our block buffer, and then we are reading this thing, and now let's say, like, we have already something is already filled and all this thing, right? So from the database, so whenever we are doing, let's say we are giving a query at select star from T. When you do select star from T, whatever data is going to come, those data is going to be stored here in the block buffer. But instead of whatever you store, like let's say it's stored here, right? And this address, we will going to insert this address in the middle of the list. Okay, so this is your LRU list. So put that thing in the middle of the list, right? So instead of putting basically in the LRU list, the problem was we are always keeping that one in the most recently used. Then what we are going to do, we are going to keep that one in the middle of the list, and also we are going to have another variable called a counter. So we give that counter to 1. That means select star from T is the first time it comes, so therefore the counter is 1. Let's say after some time somebody is going to do again select star from T. If they do again select star from T, that means again this this will be touched, right? Basically the server, the dedicated server is going to read from this block, and then the counter will become 2, and then what happens, that block is going to move. So that address, that means this address, so let's say this address is 7, so this 7 address is going to move to the top, and then so on, like if this is really used a lot, popular, then it's going to be in the top. Okay, and then what are the least popular, so they're going to go drop by, and then they're going to come to the bottom, and then eventually they are going to edged out. Edged out means something else is going to be written on those blocks. Okay, so if you do this, so then we could able to solve the problem of the LRU list, because we will not going to flood anymore the buffer cache. So another thing that always happen, like whenever we are going to do this thing, so whenever we are going to do this thing, it may happen that several Oracle process, like whenever doing the select star from T, it may happen that several Oracle process may be trying to touch this buffer cache. So in that case, unnecessarily the counter number is going to increase. To prevent that, Oracle introduced a a hidden parameter that is called db underscore aging underscore touch time, and by default, so this underscore parameter, so by default this parameter is set to 3 seconds. That means if we are going to touch within 3 seconds multiple times, this will be counted just as once. So let's say this is your timeline 0 3. So let's say within this first 3 seconds a lot of different processes are touching this buffer for 50 times, but what is the counter? The counter value is still 1. But after 3 seconds, if somebody is doing something, then its counter value is going to increase to 2. So again after 6 seconds the counter value is going to increase to, if somebody touch this block, then going to increase to 3 and so on. So that is how this is going to go up the list. So this is what is a touch count, and then how this helps. So another way that we can think about that, so we have this called block buffer, and this block buffer is going to be managed by LRU plus touch count or just only touch count algorithm. Alright. However, there are some data we want to keep forever. Okay, and what they do, they have another pool which is called keep pool. Again, the similarities of block buffer and keep pool is that all of them stores the user data or data blocks, but keep pool is going to store the data for longer time than the LRU list. We, for example, in the real life, this thing, we have something called lookup table. So lookup table is something that we always wants to check. So put the lookup tables data on the keep pool. That will make sure that this thing is going to stay more time. Have you been stored those things in the block buffer, then there is no guarantee that lookup table will be kept in the hot part of your list, or the hot part of your LRU list. Okay, then we have another thing called recycle pool, so which is just opposite of recycle pool, which is just opposite of keep pool. Whatever you're going to put here is immediately going to be rewritten. Okay, so keep pool we are going to keep for more time, recycle pool we are going to keep for 0 time, just use and then remove, and in the block buffer it's in between, so it's going to be for more time. So one more thing that I want to discuss, like as you discussed, that we have in a database we have a block size, and that block is basically copied to your block buffer or memory. This is your RAM and this is your disk. So starting from Oracle 9i onwards or release 2 onwards, you can have multiple sizes of database block buffer, so multiple sizes of the DB block size. So if you remember that we discussed a parameter called DB underscore block size, so this determines how much is the size of the block. Okay, so that you need to create during the database creation time. So what Oracle 9i onwards, the feature is that you can create multiple DB block sizes. So if you create multiple DB block sizes, then also you have a multiple buffer pool. So what we have discussed here is just the default buffer size, but what we can have another buffer size that is called DB 16K. Let's say it is a 8K block by default, so that's a default, and then we have a 16K which is another block size. Then I will have another memory which is exactly similar to your DB buffer cache, but the the individual memory inside that will be 16K, and the area name is called DB 16K buffer size. Okay, so this is how database buffer is managed, and this is the most important tuning parameter that you need to understand to make sure that your database runs in a performing way.